Hi everyone. In the first video on jitter, we looked at the basic jitter matrix and how it's made up of 4 planes that hold our color values. They hold our alpha, our red, our green, and our blue values. So we made a 16 by 16 grid, a matrix, and we filled each of those planes with different number values to generate these kind of procedural color patterns, right? So now that we understand how our matrix holds data, today, in the second video, I want to look at how we fill it. So we're going to use a webcam or a saved video file, and we're going to think about how we can manipulate that matrix data to create some interesting visual effects. So we're going to look at ways of mixing matrices, we're going to look at manipulating color, and we're going to look at ways of moving our video. Okay then, let's dive straight in. So I've got my new max patch here. We're going to start straight away by making a new jitter matrix for today. So that's jit.matrix, and then I give it a name. I'm just going to call it webcam. So we know we're using 4 different planes, alpha, red, green, and blue. So I'm going to set my next argument to the plane count. We know we're using 8-bit characters. And we're going to set the dimensions of our matrix. Okay, so last time we just used this 16 by 16 grid. Today I'm going to use something quite a bit bigger. I'm going to go 1280 by 720 because I have a 720p webcam that I'm going to use. So we've created quite a large matrix already. The next thing that we're going to do is we're going to figure out how to start filling this with data from the webcam. Now we do this with the jit.grab object, okay, and we are just going to set that same dimension size here. So I've got 1280 by 720. Feel free to use something smaller. I'm just using it because you're going to be staring at a video of my face for quite a while, so it makes sense to kind of have a decent quality one for the time being. I have a slight complication for me because I'm recording this video on this webcam, the normal webcam that I would use. I have to set up a second webcam that I'm now going to set this to. So for you at home, if you have a webcam, this is kind of all you would need to do. So we would at this point have the jit.p window. You could connect that up here, and then what else? We are going to remember we need to clock have our matrix to update, and we would do this with the QMetro object, and then just set a toggle into that. And then you could hit go, and actually, well, nothing would happen for you just yet. You would need to also send a message to say open to the grab object, and as soon as you hit open, that says okay, let's start bringing in data from the webcam. You'd hit go on the toggle and it would work for you. Now for me that would cause a problem because it would default to my normal webcam, which is the one I'm currently filming on. So it would get confused and then it would probably crash. So what I'm going to do is I'm just going to set an additional argument here. I'm going to say vDevice, and I believe 1 would be my backup. Or is it 2? Oh, this is going to be trial by fire because I may well crash my webcam. Let's find out. There we go. Okay, all things are going well. So you at home won't need the vDevice argument. You can ignore that for the time being. In fact, what I will do, I'll actually set it so that when I lock my patch, it will disappear. So don't worry about that. All you would want to do normally is hit open, set your toggle going, and you should all of a sudden be getting live video from your webcam. Conversely, when you want to stop it, or if you want to, you can send a close message and it will stop. So I'm moving, but I've frozen, and it will stop bringing a feed through, even if it's being updated by the QMetro, because remember the QMetro isn't sort of driving the feed from the webcam, it's just saying update the matrix again and again and again. So we'll have that going, and that should be all that you need. Now, if you don't have a webcam on your computer at home, all is not lost. You can very easily kind of have a workaround for today, and you would do that by just using a pre-saved video file. Now, you could use any kind of video file. I think any sort of .mp4 would work, and you could drag it in and use the playlist object. Max has these nice preset kind of useful things on the left hand side of your window, which are really helpful if you just need something you're in a fix and you just need some audio or some video. So you could also just click the little video icon here, and you could drag in this, which is just, if you set that to loop, you could also have a jitter window, and you could hit play, and you could also have a video that will just run on a loop. Okay, so if you don't want to or can't use your webcam, you can just have that going, and that'll work. Okay, so for the time being, I'm going to get rid of that because we're just going to focus on my webcam for the time being. Now, that was all pretty easy, actually. That's kind of item 1 ticked off of the video, how to get video from your webcam into a jitter matrix. There we go, we did it. Okay, so the next thing I want to start to think about is how we can take this matrix data and we can start to work with it, how we can start to do interesting things. Now, the first kind of thing that I would like to look at is kind of using various operators to kind of change the values in our matrix. To make a good demonstration of this, though, I'm actually going to bring back the example that we used in the first video, the grid of kind of random colors. So I'm just going to make jit.noise, and I'm going to hook that up to a matrix, a separate matrix, and we'll just call that noise, and that's going to be 4 planes, same data type, 8-bit characters, and this is just going to be an 8x8 grid, really small grid. Okay, and I will hit, I'll put a little bang here just to trigger it, and that will give us didn't set the same info there, so it was just generating 1 item. There we go. Okay, right, now, so what I have here is 2 jitter matrices right now. Okay, I've got one that's my webcam, that's my face, and I've got one that's just these kind of test colors, right? This very simple grid. Now, what I want to do is I'm going to use jit.op, and that's as you can see here, it allows us to apply binary or unary operators. What does that mean? Well, I'm going to use some very simple operators here, like addition, subtraction, multiplication, division, to kind of combine these 2 matrices, the one of the webcam and the one of the colors, and we can see what they do. Now, the first thing to point out, this is where jitter objects start to behave a little differently to max objects. A lot of the time, the way that we kind of specify arguments needs to have a kind of flag attached to it to say what that argument is, because there's so many different arguments. It doesn't work quite the same as, so you see here in the matrix, it goes, we have jit.matrix, then we have the name of the matrix, we have the plane count, we have the data type, and we have the dimensions. Now, luckily, they're the kind of basics, but on something like jit.op, we have so many variables, so many arguments, we need to specify what they are. So actually what we then need to do is we have the @ sign, and that allows us to kind of say what we're working with. So I'm going to then do jit.op, and I'm just going to do plus. Okay, so all that's saying is jit.op addition. Okay, and then I will just bring in these 2 feeds. We'll take a third one here, and we'll see what that does. Okay. Why is that not updating? That's not updating because the matrix here isn't being updated. Okay, so I'm going to take my Q Metro, throw that over there. There we go. Now, all I have done is I have added together the values in this matrix with the values in this matrix. And what we've got here is a combination of the 2. Okay? It's not quite mixed in the way that we'll look at in a second. this is, the values have kind of shifted slightly. They've kind of been added based on what is there. So if you look, the shades of these colors are very slightly different based on what we've got here. It's almost like an overlay filter in Photoshop or something like that. So we have different options as well here. So this is addition. We could also try subtraction. Okay, interesting. Again, we're changing the values there. Let's try multiplication with the asterisks. Oh, that's interesting. That's actually kind of a bit closer to the kind of original, which works for us right now. And then, but we've got a whole raft of other options. So I quite like the addition modulo, which is that, which is kind of nice. It's kind of got some different things. Actually, this works really well if you. Let me just turn, because otherwise it's gonna. Oh, there we go. The only thing about the playing videos is that it also plays audio direct to the sound, which kind of annoys me when I'm doing this. If I get rid of this for a second, if I take, I quite like that. It's the difference between the two video feeds. One is the basketball being moved, and one is me, and you get some really interesting. So let's just try some of the other ones that we saw a second ago with a moving second feed. So this is multiplication now. That's kind of interesting. What about subtraction? What do we get there? Ooh, yeah, we've got some kind of inversion going on here, right? Kind of interesting. So you know, you really do have to think about the stuff that you're feeding into that, because it's a very different effect when we just have something static like these colors. Okay, it doesn't quite, you know, it's not quite as dynamic, which is okay. So yeah, so we have this way of kind of making these simple operations, which can be really nice. We can also specify. Let's unhook this again. Let's get rid of this for the time being. Let's try something different, but provide an argument. So where I did the @op, that allows me to specify what operator to use. If I do @val, that allows me to specify a value. So what I'm going to do here is I'm going to use this, the exclamation point with the subtraction next to it is kind of subtract from the value. So I'm going to say 1 minus the value. That when I say the value, it means the value for every single cell in our matrix, right? So what we're basically going to be doing now is subtracting the value from every single cell, every single pixel in the webcam feed matrix from 1. And we get this kind of inverted pattern here, which is kind of spooky, right? So I don't have a second feed going in right now. Instead, that second feed has just been replaced by this value of 1. Okay, what would happen if I just, instead of that, had this? Yeah, we get a similar sort of thing, but with the colors. Okay, that's kind of fun. I'm into that. Okay, let's lose our operator for the moment. We might come back to, I'm going to hold on to it for a second, because we might come back to it. So I'll leave it up here for the time being, and I'll just move this out of the way. We might come back to it, we might not. Also, notice that the image stays there if I'm not updating it, okay? That's something to bear in mind. So if I were to just turn off the Q Metro, you see I keep moving, okay? But it's sometimes you can kind of think, well, why is this not working? It should be updating, and it's just because it's not being clocked. Let's take a different way of kind of modulating all of the values in our jitter matrix at the same time. Let's look at jit.scale bias. Okay, now jit.scale bias is going to allow us to change the values of our different planes. Okay, so I've got my R scale, my G scale. Oh, actually, I need an input there. B scale. Oh god, I've just realised, why have I done... Hold on, I'm going to show you something, and then you can all roll your eyes at the reason that I did it the hard way, because I forgot that they made an easier way. So I'm passing this through these messages with the $1, which, remember, means the kind of input value. There's a much easier way of doing this. For you just go to attributes, and it gives you a nice, like, so where's my R scale? Yeah, it gives you a much nicer kind of way of controlling it. But I forgot that that existed, so I've made this. I'll do it in the next examples. Anyway, let's take this. Here we go. Now, what we've got is let's set that to 0, set that to 0. It's allowing us to kind of amplify, if you think, well, yeah, amplify is a good word, amplify all of the values in a single plane. So this is going to say, okay, all of my red values multiplied by 1. All of my green values multiplied by 1. All of my blue values multiplied by 1. And that gives us our kind of normal balanced kind of image. But you can start to play around with them. So, you know, I can bring up the red, I can bring up the blue, kind of dial in a kind of nice pink tone there, just by sort of changing the balance of the individual planes. Okay, so just as in the first video where we took this approach of kind of individually drawing the multi-slider object for each of the different planes and then kind of creating these patterns, we can just scale all of the planes kind of individually using the scale bias, which is kind of fun. Yeah, I kind of like that. Bring out green entirely and just get this kind of, yeah, sort of washed out. You can play around with balance. We'll think about color again in a minute. Let's come back to color in a second. Let's, for the time being, just change tact slightly, and let's think about movement. Let's think about moving our matrix. I'm going to delete this just because I'm concerned that I'm quickly going to run out of space, but what it is fun maybe to do is to keep applying this procedurally. So let's work with the pink version for the time being. Okay, before we go any further, it's going to be useful to know a little bit about the matrix that we're working with. Now, I know that we've kind of already defined our matrix up here, and that's fine. So you could just work it out, you know, on your fingers. But if we use the JIT.matrixInfo object, it's going to tell us some useful things. So if we were to change the input, maybe you change the dimensions of your webcam up here, this will all update with us. It's also a useful tool to know about because you can find other things. But for the time being, what I want to find out is I want to find out the dimensions. Okay, so I'm going to do root dimensions. And I'll take my matrix over here. And what it's going to be doing is spitting out a whole bunch of data, but I only want the bit that comes after dim, right, dimensions. And it's going to give me two values, which I can unpack here. And then it's going to give me my X and my Y dimensions. And we knew that because that's what I put in up here. But what it also lets me do is figure out the midpoint. So if I say divide that by 2, and I'll do the same here. Now, like I said, we could have worked this out just on fingers, but that would mean manually typing these into the next thing that we're going to use. And actually I want it so that it always finds the the midpoint, even if we change something. So it's kind of useful there. So actually what I might do at this point is I might just encapsulate this just to keep things clean. Okay, so I'll call this matrix midpoint. Okay. Now, why have I done this? Why do I need to find the midpoint? I need to find the midpoint because what I want to do now is I want to start to rotate the jitter matrix, okay? So I'm going to use jit.rotor, and I'm going to hook it up here. I'll take another copy. Maybe move this, I'll make this a bit bigger just so you can see it. Hopefully this isn't conflicting with wherever my face is in the screen, probably down there somewhere. Okay, so the rotation object allows us to rotate our matrix around a point. Okay, now I'll do the clean one this time. The way that we do that is with this theta argument. Okay, so if I ramp this now, oh dear, I've rotated myself out of the screen. I'll come back, there we go. Now, why did I do that? Well, because the anchor point by default is set to x0, y0, which is here, right? This top left corner. It's set to the first cell, the first pixel. So as I rotate, it's always rotating from that point, right? And like I said, I want to work from the middle. So what we're going to do is we're going to do, nope, I need a matrix. We're going to change our anchor point. So I'm going to say anchor x is going to be this value. Anchor y is going to be this value. So now, hopefully, hey, as I change it, it's going to spin me around. So I'm just going to change this called bound mode. I'll set that to true, which just makes it a little, there we go. Oh god, oh god, oh god. It's going to wrap it. See, I'm there, rather than just doing this sort of a squashy thing. I don't think it is squashing me actually. Maybe that was wrong. I think this is just wrap. So yeah, so rather than giving me all of the previous images, which is what it did when I had, well, that was it. That was just black on the background. I guess 0 was the version, yeah, where we had all of the previous instances behind. Okay, so I'll do that. So we've got wrap, because that might help us do something else in a little bit. So that's kind of cool. We can start to rotate, change things. I believe off the top of my head that the theta argument is like, I can't remember, is it called radian? It's basically pi, I think, is half a rotation and 2 pi is a full rotation, I think. Let me just check that. 3.14. Yeah, there we go. Okay. Yeah, so it's not in degrees, it's in yeah, radian arguments. So 3.14 is going to be half a rotation, 6.28 is going to be back to the start, or 0, right? Same thing. So you could just bear that in mind if you wanted to play around with that. Why am I saying if you wanted to? Of course we're going to play around with it. Right, how are we going to do this? We are going to modulate this. We did it at the end of the first video. I'm feeling like there's a lot to get through today, so actually I'm just going to use audio to kind of drive this. So I'm going to use a phaser, and I will hook that up to, you know, phaser just being like a triangle wave. I'm going to hook that up to snapshot to give us, I think it only used to be like that, to give us kind of values rather than a signal. And I will multiply, because it's going to go from 0 to 1, 0 to 1, 0 to 1. I'm going to multiply that by 6.28, 2 pi. So when it gets to 1, it's basically going to be back where it started, because it will be at 6.28. So I will do times 6.28. So what that's going to do is just generate a constant ramp. If I turn the audio driver on down here, it's going to generate a constant ramp going from 0 to 6.28 like that, which if I hook up to the theta, hey, oh yes. So that's oddly satisfying. I can change the speed up here, nice and slow. There we go. Of course, this entire thing now is going to be us working towards sort of awful 70s top of the pops visual effect kind of kaleidoscope thing. So you've got that to look forward to. So yeah, so that's kind of nice. We've changed our anchor point so that we're not just spinning from this top corner. We're now spinning at the midpoint. We can do other things as well. We could also zoom at this point. So if I were to do a message that was zoom X, that's going to be 1 by default. So let's zoom in twice, and then another one that's, no, actually, let's make it a bit more. So we can change it. If we do that and set that up, we should be able to. Yes. Oh dear. Oh dear. Yeah, there we go. Because we've got the wrap on in the bound mode, it lets us do that. So obviously, I'm going to do this. Oh god. Well, yeah. Okay, I need to actually that. Okay, technically that would work better if it was a cycle, because then it would do a nice zoom back out. Oh god, yeah. I'm gonna lose hours doing this now. Right, we have to move on before I just lose all my time doing this. Okay, let's encapsulate all of this just to keep it tidy. I'm just going to take all of this. I'm going to go back to edit, encapsulate, and I'm going to call this something stupid like kaleidoscope. Descope? I don't know. I think I've spelled that wrong, but there we go. Okay, so let's go with that for the time being. I should also say, I mean, I'm keeping these here. I'm keeping this cable running here so that it's obvious kind of how it runs, but it doesn't have to go through the P window. It could just come straight from the object, and that would do the same thing. So that's maybe worth kind of just remembering. I'm trying to kind of keep an order here just so you kind of are able to keep track of the sort of signal flow. So let's put this up here for the time being. Let's just order that. And we'll just look at a quick alternative, because when we looked at using the JIT.op to kind of add two matrices together, there's a different way of doing it that allows us to crossfade. It's doing the same thing principally, but it's just allowing us to change the value quite nicely. So, and that's with JIT.xfade, surprisingly. And that basically will take two arguments. So I can take this sort of normal video, and I can take this one, and I can come down here, and we end up with just the normal. Now, why have we done that? Because we haven't provided any kind of control just yet. So we're going to do this with the xfade argument. That comes here, and then this will just go from 0 to 1. So So as I fade across to 1, it's going to crossfade to the other kind of input, right? Which kind of gives me this nice, yeah, very 70s cheesy music video effect, which I actually love. Yeah, okay. You know, we could easily make a slider for this. Oh no, not like that. We could easily make a slider for this. Do like a divide by 127, and that will give us a nice like easy to use kind of crossfade argument there, which is kind of nice. So that's handy. Actually, you can kind of it's not overclocking at all, but you can kind of go overboard with this actually and take it beyond, and you start getting this like overly saturated effect, which is kind of cool. You could go the other way just to... Ooh. So see, it's still mixing them. It's still both, but it's really screwing with the color values there. So keeping it 0 to 1 is going to just have your straightforward effect. Now, I can show you a fun little trick actually that we can do with crossfade, which I really love. So I'll just show you this as a nice little hack. I'm definitely going to go off on tangents in this video and just end up showing you more things than I meant to. It might be a long video, I have no idea yet. Apologies, kind of thought this would be like a 20-minute thing. But let's just look at this for 1 second. Let's, where am I going? Where am I going? Okay, I'm going to take my X fade. I'm going to come back and I'm just going to use... we're really going off piste here. I'm going to just use this video for the time being. Right, so let's take this all the way down just so we're starting fresh, just so we don't lose anyone. Right, so I've got my video here. What I'm going to do is I'm going to use the X fade and I'm going to set it on quite a high crossover. I'm going to set it to 0.9. So I'm using the @X fade in lieu of kind of putting in a slider, so it's just going to be static. It's always going to be like this. So I'm going to take that. I'm going to put it here. Put this there. Right. So I haven't really done anything there. I've basically just faded it to black. What I'm going to do, I'm going to take another one. Same deal. I'm going to plug the output here. Okay. And you might be saying, Ollie, what have you done here? What is this? What we're going to do is we're going to use this handy little object called speedlim. Now what speedlim does is it limits the speed at which a message can pass through it. Okay, it does it in milliseconds, so I'll just say 50. So what I'm going to do is I'm basically going to create a kind of like a blur, like a feedback thing here. So I'm going to go, the output of this crossfader is going to go to the input, which is then going to be the other thing that we crossfade to. So here I am. If I move, oh yeah, that's very cool. You end up with these kind of ghostly tails, right? I really love this effect. I love how like my hand kind of disappears if I move it, like it becomes transparent, and yeah, I can lose hours. Oh, why did I do this? Why did I show you this? Because now I'm going to do this, and I'm going to do this, and obviously we're going to get this effect. Yes. Okay. So that's fun. So it's, yeah, I mean, like, that's just such a simple effect. It's 2 crossfades with this like speed limiter, this kind of thing that's just causing this lag. It's just such a beautiful effect. I really love this one. Okay, I've got totally sidetracked. I'm sorry. I'm going to delete all of this. Let's come back to where we got to last time. In fact, even the crossfade was a... Right, okay. What's another sensible thing that I can show you? Okay, let's look at a different way of, let's come back to color. Let's think about color. We've done some movement. Let's think about color. So instead of using scale bias, I'm going to try two other objects. So I'm going to delete this right here. You see how my kaleidoscope that was relying on that has stopped. Now I'm going to use BR Cosa, so brightness, contrast, and saturation, which allows me to adjust those values. And again, it allows me to do kind of quite. I'll use so brightness, contrast, and saturation. Let's take this out of the way. So this is the one that I'm working on for the time being. So here we go. This is. And now I can start to kind of adjust the image. Right, so I can play with the contrast of it, play with the saturation. This is a really old webcam and it's very, very grainy at the moment. I wish I was using my nice one. Oh, my nice one's down there. So, okay. So now I am wearing saturation lipstick, it seems, but it isn't really changing the kind of the color so much, but we can do this with another similar object. So I'll bring this down here, plug it in here. We're going to use JIT.hue. Now JIT.hue allows us to do something quite nice, which is rotate this hue angle. So actually what I'm going to do is I'm going to take this back to 1, 1, 1. So it's like I'm not even using the BR Cosa at the moment. Actually, maybe I'll use it a little bit. Maybe I'll just bring up the brightness, just that'll help. Maybe I'll bring up saturation as well. There we go. But what we can start to do is play with the hue angle. There we go. Okay, so this is doing some interesting things. So whereas before, when we were using the scale bias object, it was just sort of blanket manipulating all of the red values, the green values, the blue values. Whereas now this is a little bit more complex, this hue kind of shade thing. So we can do some nice little bits there. And it's not quite as overpowering as just where like everything went pink, right? Now we can kind of get these interesting shades. We can do it in combination with the kind of brightness and the contrast and sort of start to play around with some interesting effects. And obviously we can also do the same thing that we did with the phaser or the sine wave. So we can do this and we can start to modulate these. So I could do I'll do the same thing. I'll use the snapshot object and what values do I... Okay, I'm going to change this time. I'm going to use the scale object just because it's kind of handy. So sine wave is going to go from -1 to 1, and I want the values out of that from like 0 to 700. So now instead of just oscillating between -1 and 1, scale is going to make it oscillate between 0 and 700. I plug that in here, and now we've kind of got this constantly moving color scheme, which if I got rid of this, plugged it in to this old thing. Oh, no, wrong one. There we go. Turn up my saturation. Yeah. I love jitter. Okay. Yeah, that's kind of fun. What else can we look at? Oh, okay, final thing, we could just hop back to hopping back to movement, we have this other option. So we were using jit.rotor before. That was what's giving us the spinning and the zooming. We have a similar one, resample, which allows us to resample spatially, which is kind of nice. I'm going to turn wrap on again because it's a different thing. And this time, what we can do is we can take our phaser. Where did we do that? Up here. Okay, let me just do this. So I have my phaser, I have my snapshot. And then I'm going to pass this through, I'm going to shift it, basically. But I'm going to just shift it in one direction. So I could shift the X, or I could shift the Y. I'm just going to shift Y. And what that should do is kind of create this falling effect. Hey! Right, so it's just using the phaser now to make it continually fall as it goes, and then it jumps back round, and that's what the wrap is doing, right? I could do the same thing. I could have it just shifting the x-axis, and then it will move side to side. Okay, so it's just moving left to right here. I quite like the falling effect, so I'll go with that. But you could start to, you could do similar things. So there's also, oh, wrong button. There's also scaling, which is going to do a similar thing to when we zoomed in the rotor object. It's just a different way of doing it, really. I probably want to put in a scale there just to change the value. So we've got -1 to 1. We'll go from 2 to 3, for instance. So if we were to go back in here, and if I turn off the zoom, if I just delete that, in fact actually let's just delete the theta as well. I know. Tell you what, I'm going to have theta, but I'm going to set it to 3.14, which is going to be upside down me. So then you can see how we've kind of got this. I do make this a cycle. Kind of got some interesting effects here. Now remember though that you can kind of keep I'm actually going to delete this because it's making me feel a bit queasy. You could, do some. You can always bring back crossfading there, so you get some. Oh, there we go. I can back to that. Yeah, so we've kind of been able to move this around, and we can rotate it, spin it. We've got a few different ways of zooming, kind of all these kind of interesting ways of playing with things. And they all kind of work, and you could we've got our saturation, but we could always bring back scale bias, and we could just set, for instance, what was it that we had, the red. Right, so I can bring that way up. I could also change the blue scale. So we can still do the hue angle changing. We can still play with all of these things. We can crossfade between them. We can have it animating. And yeah, so lots of kind of interesting interesting ways of working at this stage. I've got one more thing to show you, just because I think it's kind of interesting. And it's a slightly different way of thinking about matrices, because at the moment we've just been thinking about these matrix values as being something that we just sort of change all of them in a matrix in a live feed. But what if it wasn't quite a live feed? Okay, there is a really, really wonderful object that I will, it's called matrix set. And what it is, as it says here, a set of matrices for storing and resequencing. Okay, now it behaves a lot like a matrix, but it's actually multiple matrices that it stores. Okay, so we're going to make a matrix, but the first argument is not going to be the plane count. It's actually going to be the number of matrices that we want to hold. So let's say we're going to work with 10 of these, 10 consecutive matrices. Then they're going to have a plane count of 4, they can have character type, and then it's going to be, what was the 1280 by 720. Okay, so that's my matrix count. I will just use the kind of original camera for the moment. So this is just going to be normal video of me being fed in, and it's going to hold 10 matrices at any one time. So it will record one in and then knock out the last one. And we'll do that with how will we do this? Okay, I actually need just a little bang. No, actually, that's a horrible way of doing it. I don't like looking at that. There we go. So we use that, and we need to tell it when to when to save. So I'm going to just set a counter that's going to run from 0 to 9, so 10, and it'll do that every time it bangs. And then index $1. Right. So what that's doing is, every time our matrix gets clocked by the Q counter, it's sending this message, index this as one of the 10, okay? So each time we clock and save into the matrix set. And that's nice, that's fine. If I bring this down, I can't remember, does this? Right, doesn't give us anything out. Why doesn't it give us anything out? Well, because what we're trying to do, zoom in here. What we are trying to do is store it in and then play out a different matrix than the one that we just recorded. Okay, so if you think when we work with audio in Max, we have peek and poke that allows us to like save values into an audio buffer and play different values out of an audio buffer. We're basically doing the same thing here. We have 10 frames and we're saving them into this matrix set, and then we can choose which frame we play out. So think of it a little bit like stop animation, okay? We're taking these images, we're storing them in the matrix set, and then we're just going to pick them out. So what you could then do is have a Q metro again, active one is just, instead of doing the toggle and switching it on and off, just because we always want it on. Let's have doing this. But we're going to send this. This is going to be output matrix, right? So when I start to clock this, okay. Now, I don't quite know if I've got the video set up right, but there might be like a weird loop going on between what you can see in that corner and what you can see here. This is like sort of playing back wrong. It's kind of not quite right. It's looping it. We can actually make it more pronounced. At the moment we're driving the playback at the same speed that we drive the record, so I'm kind of doing this in real time. But what happens if I play it back too fast? Okay, what if I set my cue metro to 10? Oh, okay, that's not right. Now, all of a sudden, I've become someone's nightmare in kind of every horror animation ever. It's kind of unsettling. You can actually make it worse. Instead of just counting through, so at the moment I'm still playing through in the right order, so I kind of generally still have the same action, right? I'm still moving, but what if this wasn't a counter? What if this was actually just randomly playing through 10 frames? All of a sudden, things get a lot twitchier and a lot more uncomfortable. Okay, so this is like a kind of different way of playing through those. We can maybe, let's see if we can change this. What if we make this 20? Oh, no, too many. You know, we can have a bigger amount of time now, and all of a sudden things are getting spookier and twitchier. Okay, that feels like a pretty good place to leave it, to be honest. Remember, all of these kind of different processes that we've looked at, they can all be strung together, they can all be brought in. You know, I can take twitchy me and make it pink twitchy me, okay? It can also, you know, we can still be kind of spinning this around and crossfading in with other things and having them all driven by who knows what. You know, all of these things still layer up, and you can find interesting ways to kind of chain them up. Think of them like, you know, like a guitar effects pedals, but for visuals. Okay, this is you know, visual synthesis that we're doing here. So, you know, think of ways that you can layer these up. Think of ways that you can kind of bring in the different kind of patterns that we used last week, and, you know, crossfade them in. Find new ways of kind of doing kind of kaleidoscope effect and lots of really interesting things. Okay, I've had a lot of fun showing you these effects. I hope you will have some fun trying them out for yourself, trying to kind of extend them, trying to elaborate on them. Thank you so much for watching, and yeah, enjoy playing around with Jitter. Thanks.